For converting rectangular to polar or polar to rectangular, the best way to think about it is two different languages. And you need to convert something into a different language. Well, in order to convert something to a different language, you need some sort of translator, like a dictionary or a person who can translate between both languages. So in this case, our translator is these formulas. R equals square root x squared plus y squared, and theta equals tangent inverse y over x. Now these are not on your formula sheet, so these are some things that you definitely need to remember. We also have these formulas over here. X equals r cosine theta, and y equals r sine theta. So let's say I'm given a point that's in rectangular form. I have an x and a y. And I'm asking you to convert it to polar form. That means your answer should be an r and a theta. You need a radius and an angle. Well, I would take my x and a y and I would plug it into this formula. It's just like Pythagorean theorem. So plug it on in. We notice that this is a 3, 4, 5 triangle, so our radius is 5. We then need to find the angle, so I plug in my x and my y into my formula. So I have to find tangent inverse of negative 3 over 4. Watch out for your mode. I want my answer in degrees. So I'm going to put tangent inverse, negative 3 divided by 4. And I get negative 36.87. So don't forget to write your answer as an ordered pair. Here's my r and my theta. This is my polar point, 5, negative 36.87 degrees. Let's think about quadrants. 4, negative 3 is in the positive, negative quadrant. That's the fourth quadrant. Let's check to see that this is in the same quadrant. Negative 36 is in the fourth quadrant, and a positive r keeps it in that same quadrant. So they're both in the fourth quadrant. So now we're going to convert a polar point into rectangular form. So here's the polar point that I've given you, and we're going to use these translator formulas. It's like our translator. Here's my r and my theta. It's negative 4 is my radius, so I'm going to plug that in for my radius. And here's my angle. I'm going to plug that into my theta. Now, this is a perfect example of a problem that you can do without your calculator. Again, these formulas are not on your formula sheet, and you'll probably have to do them without your calculator. So let's go ahead and plug in. So we get negative 4 cosine pi. Now remember your unit circle. What's the cosine of pi? The cosine of pi is negative 1, so we get negative 4 times negative 1, which gives me an x value of 4. We then plug in for y. Y equals r sine theta. So our r is negative 4, sine our angle pi. Use your knowledge of the unit circle. Sine of pi. The sine of pi is 0, so we get negative 4 times 0, and our answer here is 0. Don't forget to write your answer as an ordered pair. Again, we just converted to rectangular form. Our ordered pair is 4, 0. So I have now converted the polar point, negative 4, pi, into rectangular 4, 0. Alright, we're going to again use these translator equations, but now we're going to translate equations, not points. I'm going to give you polar equations, for example 1 and 2, and you're going to convert them to rectangular equations, and we have to use these translator formulas to help us. Okay, so first of all, look at this equation. 2r equals negative 10 cosine theta. R is pretty easy. We can plug that in right straight away. Instead of r, replace it with this. The problem is over here is there's no r in front of the cosine, so I can't convert that to x. So in order to get an r here, I'm going to multiply both sides by r. So here we go. Multiply both sides by r. Remember, the purpose is so we get an r cosine theta. So now we have 2r squared equals negative 10r cosine theta. So now instead of writing r cosine theta, I can just write x. That's one of my formulas that we use. So I'm going to replace that with x. Now, if you leave your answer like this, it would be wrong because we're still in polar form over here. We have the r squared. Well, if we look back up here, r equals square root. Well, if we square both sides, we get r squared equals x squared plus y squared. So let's go ahead and plug that in. So I'm going to get 2 times x squared plus y squared instead of the r squared, and bring this down. Now, I want you to do some simple simplification if you can. We can distribute this too, make it look a little bit nicer. Now, double check your answer. Make sure everything's in x's and y's. There are no r's and thetas, so now I have completed my problem. We are now in rectangular form. Let's look at example 2. Now, example 2, secant. That's a problem because we don't have secant. We only have sine and cosine. So let me convert that. I know secant is 1 over cosine. So I'm going to convert secant times r to r over cosine. Now cosine's on the denominator. Let's move it to the other side by multiplying both sides by cosine. By doing this, I'm multiplying this side by cosine, and I'm multiplying this side by cosine. Why do I do that? So I can get rid of cosines here, cancel them out, and now we have r equals negative 4 cosine theta. There we go. Now again, that same problem. We don't have an r in front of here. Most people like to just change cosine theta to x, but it's not. You got to have an r in front. So I'm going to multiply both sides by r again. So I get r squared equals negative 4 r cosine theta. So there's my r cosine theta. What does that become? Cancel that out. That becomes just x. So I plug that in for x. And then r squared, remember, is x squared plus y squared. And we can leave our answer just like that. There's our final answer. Next, in example 3 and 4, we're going to convert rectangular into polar. So now I'm going to give you x's and y's, and you're going to give me an answer that has r's and thetas in it. So here's our first equation. The first equation is an equation of a line, vertical line, x equals 3. Well, instead of x, this is probably the easiest one. Instead of x, we can just write r cosine theta. Sometimes we like to put things in terms of r. Just like how we write things in terms of y, we always do y equals in our calculator. Here we can do r equals, get r by itself. I would probably accept it just like this on a quiz or test, but I still want to show you. So we divide both sides by cosine. Cosines cancel out, and we get r equals 3 divided by cosine. We then can write that without a fraction. 3 over cosine is the same thing as 3 secant. So r equals 3 secant theta. Again, on a quiz or a test, I'd probably just accept this answer right here. That's fine. Next, I notice I have an x squared. Well, it would be awfully nice if I had a y squared, because then I could just replace that with r squared. So let's go ahead and FOIL this piece right here. FOIL the y minus 1. Bring down the x squared. We get x squared plus y squared minus 2y plus 1 equals 0. All I did was FOIL. I took this piece and I FOILed it to that. The next thing I noticed is I have an x squared plus a y squared. I like that because that's one of my translator equations. That's r squared right there. So I'm going to take that and I'm going to write it as r squared. I then bring down the minus 2y plus 1, bring down the 0. Now if you left your answer just like that, I'd have to take off points because you have r and y. This is like a combination of polar and rectangular. But we need to be just in polar or just in rectangular, so we need to do something further with this y. Well, we know y is equal to r sine theta. So I'm going to plug that in. Just like that. And I would accept that answer, just like that. So your homework assignment is assignment number 9. See you tomorrow.